Today, we've got some groundbreaking news from the world of science and space exploration. For the very first time, scientists have discovered large patches of water ice on the surface of a comet thanks to the instruments aboard the European Space Agency's Rosetta orbiter. This incredible discovery, published Wednesday in Nature, solves a long-standing mystery about water ice and comets. Scientists already knew that the coma, the vast cloud of gas surrounding the comet's nucleus, is filled with water molecules. They also knew that water ice is one of the main components of the nucleus. But, until now, detecting traces of water ice on the comet's surface has been quite a challenge. Murthy Gudipati, a planetary scientist at the Jet Propulsion Laboratory in La Canada, Flintridge, California, and one of the authors of the paper, said, "First, not finding ice was a surprise. Now finding it is a surprise. It's exciting because now we are starting to understand the upper dynamic layers of the comet and how they evolved." The surface of Comet 67P, like most comets, is primarily covered by dark organic materials that appear almost black. That's because, as comets fly toward the sun, they're exposed to warm temperatures that cause volatiles like water ice on their surface to sublimate or go directly from solid to gas. What remains on the crust are what we call refractory materials. These include silicates, which are similar to rocks, sand, and dirt on Earth, and carbonaceous materials. Since these materials don't sublimate, the comet's surface becomes increasingly rich in organics and silicates over time, said Michael Comby, who studies comets at the University of Michigan and co-authored the paper. The surface water ice on Comet 67P Churyumov-Gerasimenko was discovered in two places, each several tens of feet across, in a region known as Imhotep, on the bottom part of the comet's main lobe. It was found using the Virtus infrared instrument, which scanned the area looking for water ice spectra signals shortly after the Rosetta orbiter caught up with 67P in the fall of 2014. In both cases, the ice appeared on cliff walls and debris falls, and it showed up as noticeably bright patches in visible light. It looked like there was a breakage, or something fell down on the surface of the comet, exposing a large, new area that had water ice, Gudipati said. Although we knew water ice had to be in the nucleus, this was our first direct detection of that interior ice. Further analysis of the Virtus data revealed that the water ice grains in the newly exposed areas came in two different sizes. The small grains in the micrometer range are likely associated with a thin layer of frost that forms as a function of the comet's rotation. As this region of the comet turns away from the sun, water ice condenses out of the coma and onto the nucleus. During the day, the water returns to the coma. The larger ice grains, which are a few millimeters across, probably have a more complex origin story. One possibility is that water ice in the shallow subsurface of the comet might vaporize as the comet flies closer to the sun, then move downward into the cooler lower surface layers, where it condenses again in the voids. Keep in mind that comets are very porous, like cotton candy, Gudipati said. 70% of this comet is void, and because of that, the heat from the surface doesn't go that deep. It should be noted that water ice made up just a small percentage of the material scanned by Virtus, suggesting that it's mixed in with the refractory materials in the upper layers of the comet. The research team, led by Gianrico Filacchione of the Institute for Space Astrophysics and Planetology in Rome, is now analyzing data captured by the same instrument later in the mission to see how the amount of ice exposed on the surface changed as the comet zoomed closer to the sun. In the meantime, Gudipati said the new findings have already given comet scientists a lot to work with. "We knew water ice made up the majority of the comet, but we didn't know how deep or in what condition it was," he said. "This shows that it's not very deep at all, perhaps just a few feet beneath the surface."